This is Lesson 19B in the Foundations of Mathematical Reasoning course. This lesson is about depreciation. When we just talked about Lesson 19A, we were talking about going to invest in a certificate of deposit. It gives us a definition. It's really good for you to read it first, like hit pause, read it, underline, think, and then answer question 1, jot down some ideas, hopefully on your own notebook paper. But I would go ahead and pause, read the opening paragraph, and jot down some ideas on question 1. It does state depreciation is a process of losing value. Losing value. Depreciating, it's going down. When we did Lesson 19A, our certificate of deposit was gaining money. For example, an automobile. You drive it off the lot and it's already lost money. So it loses between 15 to 20% of their value each year for the first few years after manufacture. Something good to know, and then they give us a picture. This is depreciating, and it is depreciating, boy, that word's rough today, exponentially. When we were looking at Lesson 19A, our amount was starting at $1,000, and our amount was going up, appreciating exponentially. It was not going up linearly, like for every year we go up $20. For the second year we go up $20. That would be additive and linear. This is exponential. It's going up in a multiplicative fashion when we were multiplying times that $1,000 we invested. So the question says, compare depreciation with the interest accrued on the certificate of deposit. When losing interest, like depreciating of a car, or depreciation of a car, you multiply the principal, whatever you paid, and up here it's somewhere around the neighborhood of $25,000, or is it $2,500? Yep, $25,000. You multiply the principal by the interest rate, and then, when we had our certificate of deposit, we ended up, whatever our $1,000 was, we had 1 plus, and then we did something with rate and depending on the compounding periods. But this says when you're depreciating, you are not going to be adding, you are going to be subtracting. So you'll end up subtracting that amount from the principal to get the depreciated value, but yet when we were accruing our interest on our CD, we multiplied it by the interest rate and we added that amount. So it's always good to read our objectives. We're going to understand some differences and some similarities about exponential growth and decay. The growth came in on our CD. Decay is going to come in on the depreciation of a car. That's an example. And then it says, let's write an exponential decay model. So starting right here at question 2. How much is a $26,000 car worth after 1 year if the depreciation is 15% per year? I would hit pause on this video. I would even talk to whoever's in the house with you or call up a friend and say, hey, what do you think this is going to be? Because the more you talk about your answers, the more you talk about what you're talking about, the more it's going to make sense and stick. So I would hit pause, talk to somebody, and then come back and let us talk about it together. So I'm going to say value. The value of our car. Let me get something darker. The value of our car. The value of our car is going to start with $26,000. But then after 1 year, it's going to go down 15%. So it's going to go down 15% of the $26,000. And this has to start looking familiar to what we were doing in 19A, whenever we were talking about it accruing and going up, and then we played around with it, and oh wait, here's going to be another chart where we get to play around and do the same thing. That'll be great reinforcement. So the value is going to be $26,000 minus, well, I'm going to go ahead and plug in, hit clear, 0.15 times $26,000, I get $3,900. And so I'll do 26,000 minus, oops, not a 2. Where's my, I don't know where that button is, so I'll just start all over. 26,000 minus, oh, I hit it again, found it, 3,900. And I get about, after 1 year, with a 15% depreciation, my car is going to be worth about $22,100. It's always good to look at these a little differently. And this is 1 times 26,000 and 0.15 times 26,000. And that's going to work the same as what we did in the last lesson of the 1 minus 0.15, but we were adding in the last lesson. So let's try this a different way. What if we take the value as $26,000 and we don't take it minus a percent of it? Let's just be all sorts of lazy and jump straight to an answer. What is 1 minus 15 cents? Well, that's 85. So where we did have the 26,000 minus 15% of it, well, that means we're actually going to have 85% left. So I'm going to grab calculator, do 0.85 times 26,000, and voila, we get our $22,100. So it doesn't matter how you do this, you're going to get the same answer, but your brain needs to understand both of those things that I just showed you. Again, it's a great time to hit pause and mull this around and repeat it on your own to make it stick. Just like in class, we would pause, we would think, we would look at it, but we would get to talk back and forth in class. So I always have email. You can always email me. Looking here, it says develop a formula. Did we answer that one? How much is it worth? Yes, $22,100. So now develop a formula for the automobile based on 50% blah, 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 1 year, 2 year, 3 year, 4 year. And this is similar to what we were doing in the other lesson, except we were going up with our CD value. So I'm going to play right here, and again, my pens are writing too large for me to be able to write it inside this space. So the calculation space for 1 year old, what we just did, our value, we started at, it's right here, we had the 26,000 minus a percentage of it. And that was our 3,900 and got this 22,100. But we came back and looked at it and said, you know, if we pull this out, factor out the 2,600 like we did in 19A, then we get the 1 minus the 0.15. Okay, so calculation, I can take my 26,000 and I can multiply it by the 1 minus the 0.15, which became 26,000 times 0.85, and that's actually to the first power because this was for year 1. Remember when you were compounding, you had to take the value here and then repeat the process here, write it over here, repeat the process, get an answer. Repeat the process here, write it here, get an answer. But if you missed any years, this process didn't work. You had to go over here and do it for 3 years, and for 4 years, and for 5. Oh, good grief. We didn't have time in the last lesson, and we don't have time in this lesson. So I am going to play around with the 2. I'll just say the value at 1 year. The value at 2 years. This is a great time to be a guessing person to think, well, I'm going to need to do one of these and another one of these, which is one of these and another one of these. So I'm going to get 0.85 to the second power for my 2 years. And what's going to end up happening when we get down here to 5 years is we'll do the value for 5 years. We'll do the 26,000 times the 0.85 to the 5th power, etc., etc., etc. I do want to go ahead and take time to calculate this. I want to go ahead and let me fold this one. I want to take time to go ahead and calculate the value of the car at 5 or at year 5, just to make sure we're on the same page on these calculations. So when your car is 5 years old, oh, and by the way, let's back up for just a second. After 1 year, the car was worth about $22,000, about $22,000. So let's go over here, and this is like 1, 2, 3, 4, 5 years. So right here at about 1 year, let's go up to where it is on the line. And if it was at 25,000 here, somewhere between 20 and 25, does it sound reasonable that our calculation was $22,100? And it does. And so now they're asking us a question, well, what's its value going to be at 5 years? Well, at 5 years, it's about-ish right there-ish. So somewhere between 10 and 15, so maybe somewhere around $12,000 is what we should get. Well, let's do the calculation. We'll do the calculation for 5 years, and let's straight punch this one. I usually go backwards on my own, but I'll straight punch with you guys. And so right here, I'm going to do 26,000 times, I'm going to do 0.85 and send only that value up to the 5th power, and we get that the value at year 5 is about 11536.34, and that is about $12,000, somewhere in that neighborhood. And so does it sound reasonable based on the graph? Yeah, 11.5 makes sense. It was an approximation. So this is still another great time for you to pause and think back on what we've done so far, because now we're going to make a general formula. And when you were talking general formula, let's look at our pieces and parts, because our pieces and parts are going to change. And so like looking right here, a general formula. To find the value, I'm going to need the original starting amount. And so the original starting amount could be, well, let me back up. Let me do this. It just says T years old. It doesn't want me to go to all variables. So the original starting amount was 26,000. And then inside the middle, I could write it one way with the minuses. I could write it with just the 0.85s. I'll go ahead and do this one and send it to the power of T. But I might want to still use the 26,000 times 0.85 to the T. How many ever years? Remember, it's got to be in years. Here's a general formula. Again, great time to pause, stop, think, and then let's go on to this last one. So the last question asks, based on your formula, so based on one of these, assuming that depreciation continues at the same rate, what will the car be worth in 10 years? After finding the value, check for the reasonableness. Well, we're ready to do that. So after 10 years, it doesn't matter if you use this one or this one, but I'm all sorts of lazy. I'm going to go straight for the 0.85 to the 10, and this is a great time to cut off the video, punch in what you think it is, and then come back together, and let's check our numbers, because right here, I've got 0.85, again, I like to go backwards, and send it up to the 10th power, and I hit equals. And then I'm going to multiply it times my 26,000 and hit equals. And so it's telling us we're at about $5,118.73. So somewhere around $5,000. Around $5,000. So look right here at year 10. And if we go upish to where it crosses aboutish, that's aboutish $5,000. So does it look reasonable? You bet it looks reasonable. This concludes Lesson 19B in the Foundations of Mathematical Reasoning curriculum.